analysis. Yes? Get a set of data, you have to analyze it in different ways. Sampling methods, biased, unbiased sampling methods. This is choosing the best model for two variable data. So we're going to get some tables, some data, and we're going to basically just use the calculator to figure out if I put a line with that data, is it going to be linear, is it going to be exponential, quadratic, power, or one other one that I'll show you. So I wanted to go over these different functions that we've kind of seen. Well, not all of them, like this is coming up I think in chapter 5, and this is coming up later too. But anyway, just as a refresher, a linear equation, as you know, hopefully at this point in your algebraic career, is a straight line. And it can either have a positive or a negative slope. So like if you get a set of data with a positive correlation, definitely going up that way, or it could go down, kind of bunched together like a line. All right. You might also see exponential. Now exponential, it starts out really, really slow, and then it can climb very quickly, and it looks like that. Or it starts out deep, going down really slow, and it can just kind of all of a sudden go down really quickly. It can be a growth, exponential growth, or it can be exponential decay. Either one. Oh, we spent a whole chapter on quadratic functions, didn't we? Chapter 4, which you get to revisit. Some of you will never forget chapter 4. You're going to review it again. Yeah, it's coming up. So, what kind of, at least maybe you know what kind of graph is a quadratic function? A parabola. Thank you. At least you remember that. And it could open up or down. No. A power, you don't have to remember all these. A power function is basically a quadratic, wait, before I go there. What do you notice is the difference between a quadratic function and an exponential function? What's different? Where's the variable?
Oh, the variable.
Yeah, in an exponential, the variable is the exponent. That's what could change. In a quadratic, or this is also considered a power function, the exponent is constant. Okay? Quadratic function is a power function. It's just that we do so much with a quadratic function, it has its own category. But a power function is basically the same kind of thing. It's where the exponent is a constant, and the I can't think of what that word is, I'm having a brain fart. That is your variable right there. Anyway, you could have like x to the 10th, you could have x to the -1, you could have x to the 21st. Those are power functions. All right. So basically, it looks kind of like, it could look like this, and you're going to someday get into that. You could have something like that next year, maybe. Or maybe next semester.
I hope you're kidding.
The number, that's the symbol for number of x-intercepts. Oh my gosh, that's where we're at in this world. It's no longer number, is it? I didn't even think about that. All right. Number of x-intercept depends on exponent. Okay? Now, I think I told you once about Sexy Algebra Man.
No.
Yeah. There's one other one I want you to write down here. Cubic is also a power function. What is its exponent? 3, right? We use it a lot. You will use it a lot, so it has kind of its own category as well. And it sort of looks like this. Let me pause this video real quick. Okay. So, this is all about graphing and deciding which graph is the best fit with the data, the set of data that you're going to get. So these are just basically a bunch of directions if you're at home or whatever, to make sure your calculator is set up correctly. So most of you might have this on already, but the most important thing is that you need to go to the catalog, which is right above 0. Catalog is right above 0, and make sure your diagnostics are on. So you're going to get this long alphabetical list, so go down to diagnostics on, and make sure just catalog is right above the 0.
Needs to be on.
You need to push enter, and it's got to be on. And it'll say done.
Wait, what? Eliminate Allie. Okay, obviously you don't get the jokes today.
It's okay,
Now, when you're done, make sure you have the same numbers in each column, because if you have more in one than the other, it's not going to like that. Okay? So,
Oh, I just didn't understand. Wait, is that supposed to
now we can graph it. Is the easiest way to graph it if you want to take a look at the picture. So some of you might not have the stat plot on. So here's what you can do. You can go to y equals, and just, if this is highlighted, you're all set. If it's not, you just arrow up to it, push enter, and arrow down, and your stat plot is on.
I'm being completely different.
Okay, and then let's do power and see what that comes out as. Power there's a shortcut to get to the power. You can use alpha A. You see the A there, the green A? Or you can just go and do it this whole way too if you want. R squared is 0.9704.
You wrote the wrong 0.94.
Is it Friday or what? Man. We worked hard this week, didn't we?
Yeah,
Too hard.
long. Hard enough.
Okay. So we're not done yet. We decided that cubic was the best one. So we have to now write the equation. So this is what you got to do. You got to go back and do the cubic one over, and it'll give you the information you need to write the equation. All right. So let me see if I can show you the best.
Yeah, this one's like too much work.
So take a look. Here's the general form of the equation, yes? We got A, B, C, and D. Well, what do you see here? Yeah. So you can just write the equation based on these numbers. And you should probably go to 3 maybe decimal places, whatever seems, 2 or 3, whatever seems reasonable. All right, be careful. Because what does that say right there?
It's the negative fourth power.
Ah, so make sure you look at it carefully. This means we have to move the decimal to the left 4 spots. So it's going to be y equals 0.0001 x cubed plus b is negative 0.023 x squared, and c is negative 29.2.
Let's just not. I just don't math. I definitely don't.
That's a messy one. So
Yeah.
it's a really long, complicated equation that fits that data. You can just get it off of your calculator. Mine is such a mess up here, you might not want to.
My calculator.
Okay? So that's that one. We're just going to do one more. We don't need to do both of them. They are, okay? Did anybody guess what it is?
That's exponential. All right.
It's not exponential.
Quadratic's pretty close.
I don't even know if we've done square root functions. We haven't yet. This is actually a power function. It's like x to the 1/2. It's kind of what it looks like. So let's see. This is what you get. R squared equals 0.9546. R squared equals 0.9924. R squared equals 0.998.
I didn't get that. I didn't get that.
8506. And look at this. Good luck. Yeah. 0.9999. You couldn't get any closer to 1. Well, I guess it could be 1.
It could be one.
But
Will it ever be one?
that would be like not really, I don't think it would be a scatter plot because it would be perfectly on the line, all of the points. So I don't think so. Okay, so it's a power function.
How do you know?
Yes.
If we ever are going down the list and we get 0.9999, we stop there. Or should we keep going?
You could probably stop. Because you should take a look at the graph first as well. Like, for example, if you want to add this to your power, you're going to find out soon that that kind of graph is often a power function. It's to the 1/2 or to the 1/4 or something like that. Okay? So if you want to add that graph to it. Then let's get the equation. All I ask is that you get the equation. Let's see if you have the same one, and then I'll be done. We decided it's a power, right? So go to power.
What number is that? Oh, it's A.
And it kind of gives you the general form right here.
Okay, let's see.
And then you fill in A. To the 0.4. Oh, I was right. I said x to the 1/2. I'm so smart sometimes.
0.4. Wait, why did it just go like?
Wait, what do you mean by, is it like times
Third
X?
decimal?
I just, well, wait, what are you asking me?
What is
Why
that?
did you stop at 4?
What is that
Why did
X?
you go-
Because look at it's 0.39999, and that actually rounds to 0.4.
Yeah.
So for an x, you could put 0.3998 if you wanted to, but for an exponent.
Why is it?
Now we have to do homework.